3. No, you're not, damn it. You are? Are you in choir? Yep. Okay. You are. Well, you kind of went like this. It's like, yeah, you're joking around. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. 10 of the 31. Okay. Yeah. Well, like I said, I'll figure it out by the end what we're doing. Okay, note card. Here we go. We are going to call these sum and difference formulas. So title of section, sum and difference formulas. So if we have sine of A plus B, it will be, and I want to make sure I get this right. I don't want to tell you wrong. If I tell you wrong, that would be bad. I'm sure it's sine, cosine, cosine, sine. But the day I tell you something and I'm wrong, then there's egg on my face. Yep. So this is the sine of A, cosine of B, plus cosine of A, sine of B. Sine, cosine, cosine, sine. Sine of A minus B is sine of A cosine of B minus cosine of A sine of B. So the same formula, just if we have a minus, then it's a minus. If we have a plus, it's a plus. Cosine of A plus B is cosine of A cosine of B minus sine of A sine of B. Cosine of A minus B is cosine of A cosine of B plus sine of A sine of B. Tangent of A plus B is a fraction tangent of A plus tangent of B over 1 minus tangent of A times tangent of B. And finally, tangent of A minus tangent of B is tangent of A minus tangent of B over 1 plus tangent of A times tangent of B. So all those go in a section on your note card. All right, so before we can get to the meat and potatoes of sum and difference formulas, we got to go back and remember how to work with radians a little bit better. So we're going to work with radians a little bit. What's pi over 3 plus pi over 4? What do those two add up to? Is it 2 pi over 7? We can't add them like that. They need to be a common denominator. So we have to multiply this one by 4 over 4, this one by 3 over 3. So you get 4 pi over 12 plus 3 pi over 12 equals 7 pi over 12. Okay? So when you're working with these, you have to know how to add and subtract. What if we have pi over 6 minus 3 pi over 4? What do we get? Well, what's our common denominator? No, I don't want to use 24. 12. Multiply this one by 2 over 2. Multiply this one by 3 over 3. So it's 2 pi over 12 minus 9 pi over 12 is negative 7 pi over 12. Okay. So we know how to go that direction. Now what if I add this? 5 pi over 12 equals what plus what? And the thing is, the two things that we're adding have to be on your unit circle. Oh, I talked about the unit circle. Let's get out your unit circles. Oliver Meyer, did you lose your unit circle? Somewhere in there. All right. Oh, good. So, we have to decide what two numbers on your unit circle make 5 pi over 12. Now, is there on your unit circle somewhere a 1 pi over 12? Do you see pi over 12 on there? No, I don't see a pi over 12 on your unit circle. Is there a 2 pi over 12 on there? Yep, because pi over 6 is 2 pi over 12. So this is 5 pi over 12 is basically 2 pi over 12 plus 3 pi over 12, right? Which is the same as pi over 6 plus pi over 4. That's what 5 pi over 12 is. So you have to know how to make this into this. Because you have to take what's not on your unit circle, something over 12, and make it a sum or difference of something that is on your unit circle. Take another one. 13 pi over 12. What two things add or subtract to be 13 pi over 12? So to do this, we'll say, well, something over 12 plus something over 12. Now, obviously 1 pi over 12 isn't on there, so you can't go 1 pi over 12 plus 12 pi over 12. Can you go 2 pi over 12? Well, 2 pi over 12 plus 11 pi over 12 would make 13 pi over 12. But is there an 11 pi over 12 in your unit circle? No, so you can't use 2 pi over 12. Can we use 3 pi over 12? Well, 3 pi over 12 is pi over 4. So 3 pi over 12 plus 10 pi over 12. 10 pi over 12 reduces down to what? 5 pi over 6. I think that works. 3 and 10 make 13. So that's pi over 4 plus 5 pi over 6. Both of those are on your unit circle. That's how we get to that. Okay? So you have to be able to work backwards a little bit. You have to be able to find two numbers on your unit circle that equal something. Okay, let's try one more. Negative pi over 12. What two numbers equal a negative pi over 12? Well, instead of adding, we're going to subtract this time. 0 and 1 don't work because we don't have a pi over 12. 0 minus 1 is negative 1. So 1 minus 2 is a negative 1. So then 2 minus 3 is a negative 1. Correct? What's 2 pi over 12? What's 2 pi over 12? Pi over 6. What's 3 pi over 12? Okay, how are we going to use this information? Well, we're going to use this information to figure out what the cosine of something like 75 degrees is. Now, 75 degrees on your unit circle? Sure isn't. But are there two numbers that make 75 degrees on your unit circle? 30 and 45. So this is why I gave you the formulas a little bit earlier. The cosine of 30 plus 45 is like the cosine of A plus B. The cosine of A plus B, cosine of 30 plus 45, is cosine of A, cosine of B, minus the sine of A, sine of B. So what's cosine of 30? There's 30 of you in here. You can look at your unit circles. What's the cosine of 30? Square root of 3 over 2. What's cosine of 45? Square root of 2 over 2. Minus. The sine of 30 is 1 over 2. The sine of 45 is square root of 2 over 2. Now we're going to simplify. 3 times 2 is? So it's the square root of 6 over 4. Because when we're multiplying, we multiply the two denominators. 1 times square root of 2 is square root of 2 over 4. So it is square root of 6 minus square root of 2 all over 4. That's the answer. That's the format we want. Let's do the cosine of negative 165 degrees. Oh my. How do I get to negative 165? What minus what is negative 165? Well, what's a number on your unit circle that ends in 5? $135, did you say? 225? Yeah, that's on there. What's the smallest number that ends in a 5? 45 minus what is negative 165? 45 minus what is negative 165? Might have to press buttons on your calculator to figure that out. 210? 210 on your unit circle? Sure is. So we have the cosine of 45, cosine of 210, plus, Mr. Bierschbach, no, that's right, plus sine of 45, sine of 210. Okay? What's cosine of 45? Square root of 2 over 2. Cosine of 210. Negative negative what? Square root of 3 over 2. Plus sine of 45. Sine of 210. Negative 1/2. So it's negative square root of 6 over 4 plus a negative square root of 2 over 4, which is negative square root of 6 minus square root of 2 all over 4. The answer in the back of the book will be this, negative out front, and then they'll say square root of 6 plus a square root of 2 all over 4. Either one of those is fine with me. I don't care which one you use. In the book, they just factored out the negative sign out front. And when you take your semester test, they'll do that on you too. So, but either one for now is just fine. Okay, so we've done it with degrees. Degrees are a little easier to work with than radians. So what is the cosine of 7 pi over 12? What two numbers would you add to make 7 pi over 12? That's why we did that earlier stuff, to kind of learn how to get this far. What two numbers make 7 pi over 12? 4 pi over 12 and 3 pi over 12, which is pi over 3 and pi over 4. So it's the cosine of pi over 3, cosine of pi over 4, minus sine of pi over 3, sine of pi over 4. What's the cosine of pi over 3? 1/2. Cosine of pi over 4? Minus sine of pi over 3? Sine of pi over 4. So it's it's square root of 2 over 4 minus square root of 6 over 4, which is square root of 2 minus square root of 6 all over 4. Notice how all the answers look alike. When you do sines and cosines, sums and differences, these same numbers will keep coming up all the time. Okay, tangents will be different. And we'll do tangents next Wednesday when we do sines. We're just doing cosines today, and that's it. Okay? But I gave you all the formulas that you'll need for next Wednesday. So those of you who are gone for band or choir next Wednesday, you have the formulas. Okay? Have we done enough of these, or do you want to do one more? We're good? Okay. So here's what we got. we're going to have numbers 3 through 29, the odds. But before you just get started on page number 179, let me tell you that on 3 through 9, you just add. And that's it. Just add the fractions. Just add the fractions, write down the answers. You don't have to do any more. Okay? On 11 through 17, find two fractions that equal two fractions or degrees that are on the unit circle that have a sum or difference of the number. But you don't have to solve everything out. It's just like what we did at the very start of finding two fractions that add up to be it, or two numbers. So if I have 75 degrees, it'd be 30 and 45, and that's all you write down. That's really quick. If you have pi over 12, it'd be 3 pi over 12 minus 2 pi over 12, which is pi over 4 minus pi over 6. Okay? You find two fractions, or you find two numbers that add or subtract to be that. And then on 19 through 29, that's where you use sum or difference formulas to solve. Okay? That's today. Next Wednesday, for all of you who are going to be gone, we're going to do section 3-4. And we're just going to do 9 through 16 all on page 185. And that's sine and tangent. And I'll make a video, okay? But that'll be next Wednesday's assignment for you band and choir people, okay? Sine and tangent ones, okay? So this is today for next Wednesday. This is next Wednesday, okay? So then next Friday, right now we don't have a track meet because the one that we were supposed to go to got canceled. But we're seeing if we can go to a makeup one somewhere else. So if I'm here, I'll grade both of those next Friday. If I'm not, then it'll be a work day on your semester project. Okay? All right. So there you go. Vamos. Get going. Yes. What? Oops. No. Not as of now, but like I said, we're kind of